Hello students, today I am going to teach you chapter 5 continuity. See, for this continuity you must know limit, because a function is said to be continuous only when its limit exists. Therefore you must know what is limit. I have taught you in the previous class. Previous class means class 11. Okay, in class 11 you have already got what is limit. Now you see continuity. For this there must be a function. Suppose y equal fx. Suppose I have taken the function y equal fx. This function is said to be continuous when there is no break. When there is no break in the graph of the given function. Okay, suppose this is a graph. Okay, any graph you can take. Okay, suppose y equal fx, xo, x dash, yo, y dash, and this is another graph. Yo, y dash. Now you see, this function is continuous and this is not continuous. Why? Because you see, if I'm starting from this point and ending at this point. Now you see, from this point to the end point, I have not removed my pen or pencil. Okay, so there is no break in the function. But you see, from the starting point to the ending point, I have removed my pen or pencil. You can see there is a break. Okay, so this function is said to be continuous and this is not continuous. Giving you the definition, there are two definitions. Number one, suppose f is a real function on a subset of the real numbers and let C be a point in the domain. C be a point in the domain of the function f. Then f is continuous. F is continuous at the particular point C. At that particular point C, if limit of fx when x tends to C is equals to f of C. This is the first definition. The second definition, you can go to the second definition. What is the second definition? A real function f is said to be continuous. If it is continuous at every point in the domain of f. Now you see, for this we need an elaboration. Okay, we need elaboration. What does this means? Suppose f is a function defined on closed interval ab, on closed interval ab. Then for f to be continuous, what is f? The function, okay, to be continuous, it needs what it needs? It needs to be continuous at every point, in closed interval ab, including the endpoints. What are the endpoints? The endpoints are small a and small b. Now you see, what does x tends to c indicate? I've told you in the previous class 11, okay? What does x tends to c indicate? X tends to c means this is radius tends to or approaches, APPROACHES, means x tends to c or x approaches the point c. Okay, now you see, x dash y dash. Okay, suppose this I'll take as c. Okay, I'm taking the point as c, this point c. Okay, now you see, c can be approached from the left hand side or from the right hand side. Now you know, from the left hand side this is c minus h, and from the right hand side this is c plus h. Already I have taught you, no? What is c minus h? Means c minus h here denotes all points means x, okay, towards the x-axis, towards the left of the x-axis. It denotes all points towards the left of the point, the particular point c. Okay, so we are getting c minus h means c minus h here denotes all points towards the left side of the point c, and c plus h denotes all points to the right hand side of the point c. Now you see, the definition. Limit fx when x tends to c equal f of c. What is fx? Here fx is the function, c is the point. Okay, c is the particular point. So for a function to be continuous, I am giving you again, for a function to be continuous, limit must exist. Limit must exist. What does limit must exist denote now? Limit must exist denote. It denotes that limit x tends to c negative. What is negative here? It is towards the left side of the point c, towards the left. left side of the point C. Okay, x tends to C, f of x is equals to limit x tends to C positive fx is equals to f of C. You have got already this. What is this? This is the left hand limit. And what is this? This is right hand limit. And this is the point. Okay. When left hand limit equal right hand limit equal to the point f of C, then the function is said to be continuous. Is said to be continuous. In other way, you can say limit x tends to C, f of x is equals to f of C. Now you see, here I have written C negative, the second one I have written C positive. C negative and C positive, you can write it as x tends to C. X tends to C means, what does x tends to C means? Now it contains C negative and C positive both. Okay, means from the left hand side you can come from the left hand side and from the right hand side. Suppose I have taken a function fx equals to 1 if x less than equal 0 and 2 if x greater than 0. I will show in the graph how can you plot this. Okay, and how can you test this is continuous or not. You can test but with the help of the graph. Okay, see, first plot all the points, these 2 points 1 and 2, xo, x dash, yo, y dash. Okay. Now you see, fx equal 1 if x less than equal 0 and 2 if x greater than equal 0. Means what? There are two functions. The first function is fx equal 1 when x less than equal 0, and the second function is fx equals 2 if x greater than equal 0. Now you see, x greater than equal 0 means there is a point 0, and x greater than equal 0 means that it is greater than 0, means suppose 1, 2, 3, 4, 5, 6, all this. Okay, means towards the right hand side. Okay, and x less than 0, x less than equal 0. Okay, equal 0 means the particular point 0, and x less than 0, and x less than 0 means towards the left side of the point C, means towards the negative side of the point 0. Okay, I see, I am plotting these points first. Suppose this is 1, this is 2. Okay, now you see, x equal 0, the fx equal 1 when x equal 0. Okay, for x equal 0 you are getting 1, means this point. Okay, this is the closed one. Okay, this is closed. I am denoting it by black ball. Okay, x less than 0, you are coming towards the left side. Okay, again x greater than equal 0, fx equal 2 if x greater than equal 0, means the point 2. This is the point 2 suppose. Okay, x greater than equal 0, so this I am denoting by open one. Okay, this is not closed. Okay, and this is going towards the right hand side, towards the positive side of x-axis. This is to the negative side of x-axis. This is the point 0, 1, and this is the point 0, 2. Now you see, you can see this is continuous or not. The function fx equal 1 if x less than equal 0, 2 if x greater than equal 0. We are going like this. After plotting, I am saying okay, this is 0 comma 1. See, this black bold denotes, what does this blackboard denotes? It denotes that at the point x equals 0, we are getting the value as 1, the limiting value as 1. And when x greater than equal 0, we are getting the value as 2. But this is not particular, okay? X greater than equal 0, we are not getting a x greater than equal 0 means, what does x greater than equal 0 denote? It is not denoting the point 0, okay? It is not denoting the point 0, but it is denoting all points greater than 0, means 1, 2, 3, 4 up to infinity. So this is open because we are not getting a particular value, okay? You can see for x equals 0, when x equals 0, we are getting the value as 1, means we are not removing our pen or pencil. So this is continuous. So you can see these two, this function, okay, I am saying you this function is not continuous, okay? This function is not continuous, okay? Suppose I am taking a different function, fx equal 1 if x not equal 0 and 2 if x equal 0. Now again plot it. This is y-o, y dash, this is x-o, x dash. This is not continuous, okay? Now plot these points. X not equal 0 means we can come from the left hand side or from the right hand side. 0, you are getting 1. So this is the 1. This is open, okay? This is open. You can, the graph is like this. And when x equals 0, we are getting the point 2. 0, you are getting the point 2. So this is closed, okay? This is 0 comma 2. This is 0 comma this is line, okay? This is y equal 1. You cannot say 0 comma 1, okay? In this chapter continuity, we will be given to test the function is continuous or not. Test, suppose the first question is test whether the function is continuous at the particular point x equal c or x equal 1 or x equal 2, okay? See, in the function fx equal 1 if x less than equal 0, 2 if x greater than equal 0. Here we will get 3 cases, okay? Here we will get 3 cases. What are the 3 cases? The case 1. In case 1, what you are getting? The first one, x less than 0. The first one, you are getting x less than 0. The second one, what you are getting? X equal 0. Case 2. Case 2, x equal 0. The third one, what you are getting? Third one, x greater than equal 0. See, x less than equal 0, x equal 0 and x greater than equal 0. If you are given a particular function, suppose fx equal to this, okay, you can test directly you can test directly for x less than equal 0, x equal 0 and x greater than equal 0. X less than equal 0 means it is towards the left hand side, so left hand limit. Okay, x equal 0 means the particular point f of 0. X greater than equal 0 means right hand limit. So if you are given a particular function and you are given to test it, test the function is continuous or not at the particular point 0. At the particular point 0, this 0. Okay, so for this function you must get left hand limit equal right hand limit equal to the point. What is the point? F of, and the point is 0. So left hand limit must be equal to the right hand limit equal f of 0. Then it is said to be continuous. Means limit x tends to 0 negative fx is equals to limit x tends to 0 positive fx is equals to the point. Then it is said to be continuous. Okay, if you are getting left hand limit not equal right hand limit, then the function is not continuous, or left hand limit not equal to the point or right hand limit not equal to the point, any three, then what you can say, the function is not continuous. Function is not continuous. But you see, if you are given a question, suppose discuss the function is continuous at the point, suppose x equal to 1, 2, 3, any point. Okay, so if you are given the question as discuss, then take any point C. Let C be any point, and with the help of this point you will get, suppose for this function. Okay, for this function I am saying you, for this function here you will get three cases: case 1, case 2 and case 3. So if you are given discuss, then you must take the point C. Okay, you must take the point C. So for this you must test C less than 0, C equal 0 and C greater than 0. Now you see C less than 0. How can you say that this function is continuous or not? For the first case I am saying. Okay, for this you must get x tends to C, fx is equals to f of C, then it is said to be continuous. For discuss, if you are given discuss, then for first case take C less than 0, for the second case take C equal 0, and for the third case take C greater than 0. It will differ. Okay, if there are given for this function there are two functions. Okay, for the given function fx equal 1 if x less than equal 0 and 2 if x greater than equal 0, there are two functions, so you are getting three cases. Suppose there are three functions, you may get, the cases may differ. Okay, for this you are getting three cases. In some questions you will get up to 5-6 cases also. Okay, So in the second case I am saying c equals 0. Here you must take out fx equal limit x tends to 0 negative fx is equals to limit, not limit, f of 0. See, for the second case c equals 0, for this you must find limit x tends to 0 negative fx equal limit x tends to 0 negative fx or 0 positive, okay, 0 positive fx is equals to the point. Then the function is said to be continuous. Then the function is said to be continuous. At c equal 0. The function is said to be continuous at c less than 0. Or you can say this as x also. The third one, for this you must get again fx is equals to f of c. Then you can say then it is said to be continuous. Okay, it is said to be continuous at c greater than 0. You see, the first case I have taken c greater than 0, second case c equals 0, and the third case c greater than 0. In the case 1, what I have tested? I have tested limit x tends to c, f of x must be equal to f of c. Then it is said to be continuous. Okay. Here I have taken x tends to c. Why? Can you say? You cannot. So I am saying you x tends to c. Why I have taken here? Because you see c greater than 0. I am not getting a particular point. C greater than 0. C less than 0. Okay. C less than 0. I am not getting a particular point for c less than 0. In the third case, similarly, I am not getting a particular point c greater than 0. For a particular point, you will get left hand limit, right hand limit, and a point. For a particular point, you will get left hand limit, right hand limit, and a point. But if you are not getting a particular point, then you take x tends to c. X tends to c. Okay.